Alrighty, so now we have two talks when it comes to calls for collaborative project. The first one is from Joost, Deputy Director of CSCS, that talks about ALPS.
Yes, so good afternoon, everybody. I will repeat a little bit, what is ALPS, what have we delivered in the context of, the Apertus training runs, and then also touch on how you can access ALPS, also in the context of this international collaboration that we've talked about, and then try to put it a little bit, just touch on the European context, and then I'm going to hand over to Tim, who is going to sketch that European ecosystem a little bit. And some of you will know this already, but you will go into potential opportunities to have funding or compute in Europe. So when we talk about ALPS here, it's not just the mountain range that all of you know. It's also the research infrastructure that we develop and operate at CSCS, the Swiss National Supercomputer Center, which is part of the ETH. And we do that with a mission to support world-class science in Switzerland. And of course, AI is part of that science that we support. But it's also a research infrastructure. And in Swiss tradition, that means that it's open to the world. And that is why there is this opportunity for the people here to connect to Swiss researchers and actually build together something nice. Now, we have a bit of a name in this field because we were one of the earliest adopters of GPU computing. Already in 2011, we had this partnership with NVIDIA, and we were able already to be their launch customer for two of their most advanced chips. One's the T100, and now also the super chip, the Grace Hopper 200. And when we inaugurated ALPS, this was the largest infrastructure in Europe for open science, and now we have machines like Jupyter that are coming online that when counted the number of GPUs actually are somewhat larger. Now, what does it mean? It's a piece of hardware infrastructure, more than 10,000 GPUs, but we especially proud that we have also a software infrastructure on top that enables us to make good use of this infrastructure. And this is also important because what you see today is that the ecosystem is becoming more diverse than it was before. It's no longer a single workload related to scientific simulation, which is kind of the origin of HPC, but we are serving different communities. And we had this morning already a presentation of Atlas. That's one example of a workload that actually runs on ALPS. And when I tell the people here that they should clean up their disk space, it's because they're competing on a shared resource with actually these guys of Atlas. Now, we want to make sure that we can have these different communities on one shared infrastructure so that we have the benefit of scale, but also that we can tailor for these communities. And that is this vCluster concept, the software-defined infrastructure that ALPS is. And the machine learning platform is one of these domain platforms that enables the machine learning community to make use of ALPS. Let me have a look at that. So, this machine learning platform is one of the vClusters on ALPS. This is the Clariden cluster that you might have heard in some talks or in some presentations. But it's also important that this is a composition of services that we try to develop, to serve that community best. And that means, for example, Clariden, contrary to other systems, is a container-first environment where people can more easily deploy containers with, the NVIDIA software stack. Or we have specific tools that simplifies it to do a performance analysis of an ML workload. When people submit for a call, they have to provide performance data, and we will provide tools that make it possible. We have to understand the performance. So what is the infrastructure observability that we have? Can we monitor GPU performance, temperatures, store that in a database, and keep track of that? Also, when we do these large runs, and I will talk about that, can we guarantee the quality of the nodes? Do we have monitoring tool? Can we learn from the community with their benchmarks what is needed to actually say that a node is in a good shape or not? And then this is mostly focusing on the standard kind of batch processing, those Slurm-based cluster, but we'll also have service planes for other workloads that are not traditional for an HPC center, but that are, central to AI. For example, an inference platform. And, the link is there. CSCS has an inference endpoint where you can, for example, use Apertus, but also some of the open weight models that have been presented today. And that is useful then for research purposes, or, if we have SMEs or companies, they have something where they can start building products. And then things like, storage services. I think the comment was made here today. I don't know what's about the data sets that you've used to train Apertus. Actually, my observation, handling the data is one of the most critical parts of these, large efforts. How can you version the data, know what has gone in, what are the scripts and protocols to actually reproduce these training runs? And I think this is not yet a solved problem. And there were some more presentations saying that, some framework that makes it possible, to reproduce these training runs at different places would be really nice. And I think, yes, that is definitely one of the things to look into. Now, why were we? I mean, I was personally very happy. I think back in April or so, something this year, we had at given point solved, most of the problems that were affecting ALPS. We sorted out some of the problems of the kernel with, basically every piece of software on that machine. And we were able to compare, the performance, the throughput on ALPS with data shown by Meta. And it basically says that, the quality of these systems is at the same level. We are able to compete in quality with these big players, but of course we don't have the capacity of these organizations. But it's very important to demonstrate that knowledge is there, that the skills and engineering that are needed to do these large training runs are available. And then I think another thing we did very well, and that's also kind of a call to action to my European colleagues, is when we decided to go for Apertus, the large-scale training, what we did was really dedicate essentially half of ALPS to this project. So we basically said, this is a priority project. We will dedicate at least 4,000 healthy nodes for 3 months to this project to succeed. And we do everything possible to make sure these resources are available and try with priority to happen, that this works. And this was a very long engineering journey. This was certainly not easy, not the least because this was new hardware and kind of a new system. But eventually we could show graphs like here where you see that the full partition was fully employed and we had steady throughput and good performance. And I think when I look, for example, and people of Open Euro LLM are here now, we know if your HPC hands out these resources, they give, a fraction of Jupyter, 2.5% as strategic allocation over a 2-year period. And I think this is not the right strategy if we want to deliver, frontier models. We will have to be able to guarantee a large fraction of these resources dedicated to these projects. Now, how can you access CSCS? And I basically put here what I see right now as like the 3 main tracks. The middle or the left part is what we call the peer-reviewed tracks. This is where scientific excellence goes. Researchers submit a proposal. They are peer-reviewed by international committee, and they get access. That's something we have established for a long time in what we call the user lab, and we've mirrored something like that in the Swiss AI call for proposals. And for this community, where foundational AI is the focus, you can go to the Swiss AI webpage and look there at their small and their large calls. The small calls are basically quick processes, a rolling procedure that should give you access to demonstrate your ID and ultimately leading to a large call. And then the large calls are there for proposals that need several 100,000 GPU hours. There is also the third column there, which is access to resources for a fee for at least academia in Switzerland and the private sector. This is a pathway to get access to resources without the need to go through peer review. And then my last slide is Switzerland is also at the heart of Europe, quite literally shown with what is the AI factory antenna proposal that we've submitted. So we are an AI factory antenna. That is, we are associated with a number of centers in Europe that are the AI factories. And we are, in close contact, and in this way provide a means to access resources and also to share knowledge. In this case, we are associated first and foremost with Lumi, which we have signed a letter of intent. And we've also signed, memorandums of understanding with the Mimer AI factory. The other way around, my boss is signaling me. We have signed letters of intent with Mimer, Barcelona Supercomputer Center, and then Cineca, the AI Italia thing. And we are in close contact also with the Greek AI factory. This is based on some more history. Switzerland also has infrastructure, not only in Switzerland, but also as part of the Lumi consortium. So we have also a way to access Lumi resources, but Switzerland owns a share and, can, provide direct contact via EuroHPC to the resources there. Let me close there. We have infrastructure. We have the wish to share what we've done in Switzerland, both on the software stack, on the software infrastructure on ALPS, but also, for example, with projects like Apertus. And we are strongly convinced that if we want to move further, we have to collaborate internationally because the next scale of models will be larger than what we've done today.
Question for Joost. I'm curious from the experience of training, purchase and obviously those 4K GPUs. Is there anything you learned that you want to change in how you ops or you organize your cluster?
Yes,
that's most surprising.
I think there's a lot of lessons that we've had. We definitely ran into issues, for example, because the software stack was relatively old. Like things like the kernel that was the production or supported kernel of our vendor, which was not up to date. But also, I would say from the user side of view, the way the software stack, Megatron and variants is managed, it would need, kind of more productization, make it operational, have, continuous CI, and, on that, have everything well documented. I think these are at least two of the things. And we have to work closely together with the center that we are and the AI center that the domain, and that is also something we are trying to continuously improve. I think that for me the key learning.
Stronger network.
And a much stronger network on the machine. So our next architecture is probably
not complaining about storage yet. Storage is our biggest fail.
So we have invested in storage like probably not, but because of climate. But the network. And I think that's the message to the data science community. If you think in the past that, there's HPC and dinosaurs that nobody cares about, and data science works on the long tail, on small things, this is completely not true. The most demanding supercomputing application I've ever encountered was training of Apertus. I've been in the business,
which actually makes it
years.
actually for me was a fun project. The fact that you have to drive this for many months. I think that's what these kind of resources are actually conceived for. So this is their goal, to be able to enable that. You talked about the storage, and of course storage is a pain point. In part controlling the community that likes to grab all storage. But also the fact, and that I think is special to HPC centers, we have mixed workloads. This is not an AI cluster dedicated only to AI with dedicated storage. And so we have literally the Atlas experiment on the same file system as Swiss AI. And when Swiss AI was filling the file system, the Atlas experiment was going down. Or when the Atlas experiment was running at full throughput, Swiss AI was suffering on their throughput. So that is part of the real world.
The cool is that makes a ton of sense. Like we change our own trainer to be more aware of the platform we're running on. So for network, we basically do some on glue, some on TCP/IP, depending on what happens. Storage, we implement a lot of async checkpointing because of the location.
Async checkpointing, different file systems for checkpoints, different file systems for data. this is all being done. And I think, that's part of the whole,
I think we need,
yeah, we have.
if it's a yes or no question, yes, otherwise we can keep it maybe for the, okay.
Have other HPC centers in Europe sought your advice after training the LLM, how to train LLMs on their devices? on
Yes
their
or no?
computers?
It's insufficient.
No.
Let's make more time.